Yeah, I'm on it. Yeah, it's taking a bit.
I see it on my corner now, so I think it's working. All right. Reminder to sign into the document if you haven't already. Most of you haven't. Release planning and updates.
I guess I should mention that we're planning to cut a patch release of the life cycle. We discovered a couple of bugs with the SBOM implementation, so look out for that in the next day or so.
Any updates on the platform side?
I believe I was absent, but there was an RC, if not a new release going on. I don't know, Sam, if you have more context on that.
Yeah, we released a pack RC with platform 07 and 08 support. So that allows for all the SBOM stuff. I think we should probably wait for the lifecycle patch before we ship the actual release out, because that will fix the two SBOM restoration bugs. So that we shipped out libcnb with all the SBOM stuff. I think it's being used by the Ghetto folks. Also reached out to the Google Build Pack folks, and they're interested in joining and giving us feedback, and they'll probably also be moving over to the new API, hopefully.
Awesome. Any other subteam updates? We will move along to, I think the RFCs are supposed to be a little flatter, or I guess all those RFCs related to project descriptor. Yeah. I think project descriptor, that was you, Joe.
Yeah, sure. I can kind of drive this one. I think we've got, there's 3 RFCs that are a part of this. One was in addition to Project TOML that potentially introduces an images table, and that I think that kind of prompted some larger discussions around Project TOML as a whole, especially since this is one of the cases where it might be difficult or inconsistent across platforms, and how that's supported, or if that's supported, having multiple images output from a single build. So I created an RFC for a pack TOML, which is a pack specific special case of Project TOML. And I think Javier created another one that's sort of a new project, or a new descriptor that's build packs with an S, TOML, and or YAML. So I think it'd be good to talk through some of those and figure out where we want to take project descriptor, because I think it's an important topic because it is a key touch point for any build pack user. And there's a lot of cases where I think we're held back by kind of waffling on how we're going to support this or what it means. And so, yeah, so we could get off there. I can go ahead and start. I guess I was just gonna give other folks a chance to sort of rebuttal what I was saying or whatever, but I'm also happy just to dive into what my thoughts are.
Yeah, I think I've discussed it with some people in the pack RFC. That's a relatively new one. So if maybe we could go over that one and see what the idea behind it is, that might help influence some further conversation.
Yeah, makes sense. So I'm pulling it up right now, but I think the thing that the real differentiator for this RFC from other proposals or from the status quo Here, I can share this too. Is that this is a pack specific configuration file, as opposed to something that's meant to work across platforms. And I think like in some ways this is accepting the thing that's been a problem for a while, and that like we want to expand the scope of Project TOML. We want it to be more ubiquitous to the project, but there's things that pack can do or wants to do that maybe KPAC can't do or doesn't want to do, or Tecton, you know, in the worst cases, like can't do without additional tooling. So what I'm proposing in this RFC is a new file, pack TOML, that would ultimately adhere to the same specification as Project TOML, but would be scoped just to pack. So you could omit, so it would ignore anything outside of the IO build packs namespace, but would, you know, but you could use it as a sort of a minimal set of what's in there. So you could configure, for example, just build packs. And, you know, my thinking is that this would allow us to introduce things that are specific to pack that supplement a Project TOML. So if you have configuration that is meant to work across platforms, that belongs in Project TOML, and you can assume that any platform that supports Project TOML, that configuration will do something on that platform, and that allows us to kind of keep Project TOML sort of slimmer or less opinionated, whereas the pack TOML can be more explicit and like these are the things it can support a builder image, and we don't have to put that in Project TOML. But that separation between pack TOML and Project TOML, I think, gives people a good like cognitive model of what will be supported by pack specifically versus what will be potentially not supported by KPAC or something else. So yeah, I really intend this just as a starting point too. Like I'm happy to iterate on this.
Wouldn't that IO build packs pack key, like, is it because we have that namespace, right? What's the reason to introduce a new file as an additional namespace and then restrict the other file to not be able to use that key? And I say that I think Project TOML is too generic of a name, or like the format is very generic for build packs. But introducing a new file that has the same format, I like that the name is more clearly build pack associated, but introducing a new file that has the same format and then kind of two levels of extra name spacing in order to move out the builder configuration, you know, like I like some parts of it, but I feel like the motivation behind it is different than what my motivation would be for introducing a different project descriptor file, if that makes sense.
Yep, makes sense. I was thinking the same thing as an alternative. Like one alternative is just add this to Project TOML and have the sort of the same thinking behind it. We could also do things like simple, like remove this reverse names domain name thing from pack TOML just to simplify it, but make it, you know, essentially similar to Project TOML. Yeah, I mean, I'm open to all that kind of stuff. The main reason to have the separate pack TOML, I think, was to, you know, advertise or communicate, but more specifically to communicate compatibility with pack. Like I worry about broadly communicating like a build pack file or something like that when we really can't agree on what would be required to be supported by all platforms. And I also worry very much about that actually being true in reality, right? Like we can say, oh yeah, you got to support this builder, and probably half the platforms will.
Well, I wonder,
can we ask about, you know, what is the broader plan for the rest of the platforms, right? Because I'm sure there's discrepancies between Tecton and KPAC too, right? But, you know, does using the Project TOML for both of them imply that they have to sort it out, but pack can be the outlier?
I don't think we've established anything, right? Like I think they are divergent, and We haven't really set out a plan for whether that's okay and how you should handle, or what should be expected in that case.
Just sorry, go ahead, Steven.
Oh, I was going to say, I really like the idea of removing the domain prefix, right? If the file's goal isn't to be like Project Toml's goal was to be something larger than the project to some extent, right? Like a kind of generic way using Toml to define kind of what a project or application looks like. If we're going to focus on something that's more build pack specific, I definitely like the idea of removing the domain notation. But I wonder, or I guess, and I wonder though, at that point, if you have a build pack specific file, if you could, instead of making it, because you want some parameters that are platform specific to be a pack specific file, could you instead introduce like a platforms table or something that, or you can say like, you know, for pack, builder equals this. If we really feel like we want to keep that kind of platform specific configuration separate, can we just, you know, define a table in the file that allows you to specify platform specific configuration? It actually, and on top of that, it doesn't bother me that much because a builder is kind of a term in the project. If, you know, builder is a top level thing and you can set it and it doesn't do anything on other platforms where it's not settable, and they just complain about it. That option is actually okay with me too. But a platform specific table would clean it up.
Yeah, what you're describing just sounds like inverting what we already have. Like how would that be different from just renaming Project Toml to Pack Toml? Like you still have like domain, reverse domain to put platform specific configuration, and we still have stuff that's build pack specific under. Is it just simplifying the namespace?
Yeah, the reverse gets rid of the reverse domain notation because there's no, once it's a project specific file, there's no reason to namespace. Once it's a build packs file, there's no reason to namespace all the keys under IO build packs. You know, in retrospect, the domain notation doesn't make it look like other Toml files, if that makes sense. Or it's like,
sure,
you know, it'd be a nice simplification. But I think it's similar. It's just that it makes the file more of an advertisement for the build packs project and simplifies the keys.
The one thing I want to throw maybe in there that kind of applies to this, and maybe even Stephen, your idea, is the challenge of keys that we've at this point in time kind of introduced at a build packs domain. For instance, build packs, right? So like I believe we have like IO build packs dot build packs, right? Where you are able to define build packs. The way I'm interpreting this is that this pack Toml would inherit and use those, and we're saying that because they're at that domain, right, that KPack should also respect those, and that Tecton should also respect those. And obviously that's not necessarily true. So what then that would mean is we would have to move those build packs into platform specific configurations. So then what do we end up with at that generic level?
Oh, I don't know if we have to move concepts that are defined by the project, right? Like this is the group of build packs. If the app developer is going to provide a group of build packs into a platform specific key, I think platforms can just choose not to respect that configuration if they don't want to.
I think that's the problem that I'm facing, right? When I talk about the expectation from the end user and the challenges of taking my application and running it on Pack versus running it on KPack or Tecton and yielding different results.
I think the only, if you go to the level of like, we can't have a list of build packs because KPack sometimes doesn't accept, or KPack currently doesn't accept a list of build packs, or it's okay for a platform to mandate that certain build packs be used instead of letting the developer specify it. At that point, I feel like there's very little value in having a descriptor at all. But I think there is value in having a descriptor because I think it lets you have a unified way of encapsulating that configuration when you're going to provide it, even if it's not perfectly portable. Yeah,
I guess I disagree with that, right? I'm with you that I don't see the value if we're breaking it up into individual platform stuff. Then I would say every platform should just provide their configuration element. So like in this case, Pack Toml, right? It would be a pack specific. configuration. KPAC could have something very similar, and Tecton and so forth.
But why have them have all different ways of specifying the same, essentially the same data? And it could all be in the same schema that could be compatible when the data is compatible.
I think it's the challenge of security, right? Where now, as a user, from a user's point of view, there's unexpected behavior, and what properties are actually respected are completely unknown to me, right? Because there's nothing, at least right now, structured. Like the project descriptor is an extension, right? So like platforms may completely ignore it. Things like that we think should be on there, like exclude and include.
But I think this isn't. I think there is a lot of prior art for this. Sorry, Sam. One point. There's a lot of prior art for this. It's like if I use like Cloud Foundry as an example, or I'm sure Heroku has things like this too. If Cloud Foundry is configured so that you can't push Docker images, that doesn't mean that the Cloud Foundry's manifest YAML shouldn't have a Docker image field, because some platforms or some foundations are gonna support it and some foundations don't. It just means that when you use those parameters, the platform has to make it clear that that's not accepted configuration in that context. So maybe the most portable thing to do would have KPAC say, you tried to set the build packs and just fail to build, right? And then
yeah, and I think that's what I'm saying is I don't want to hand wave it. I want to make it strict that the platforms have to say that I am ignoring certain things or your build should fail, right? That's kind of my stance. I want to be a lot stricter on that. Whereas right now it's going, it's basically these warnings or errors are being swallowed and the user doesn't know anything about it. And they just end up with different results.
Yeah, I agree that the platform should be very loud about when there's configuration that's not going to respect. If that's your issue with it, then I definitely, if we move in the direction of a generic configuration, I think that's right.
The extreme example is like Google App Engine, which will not ever respect any of these descriptor files probably. And they're not going to be loud about it. Like their opinion is to very much just hide that from you, right? So I'm not sure we can take such a strong stance in terms of our opinion on that.
I bet if you told Google App Engine either respect this file or fail if somebody specifies it, they wouldn't be opposed.
Oh.
Sorry, Sam.
I really don't know. Yeah, go ahead, Sam.
I was just going to say that we discussed a random alternative, which was that, so there are other languages or something that have a similar issue where they have external like build systems or something that can be plugged in and process your files before the actual one comes into play and does things. And the way they define it is the spec defines that here are the keys to specify this prepare phase or whatever you want to call it. And that implementation will be used to process the rest of the descriptor. So and like one such prepare phase would encapsulate the list of features that a platform respects or wants to respect. So the idea is, let's say I have prepare secure or something like that, which is something that KPAC, Tecton, and PAC can support. So you put like prepare phase equals prepare secure, and that's like a binary that can do things consistently and can be reused. So like things like inclusions, exclusions, setting environment variables, or whatever else is handled by that. And the platform explicitly allows us the list of prepare versions or phases it allows to be run on itself. So it can either be like something like this or a list of keys that the platform says that from the default prepare implementation that we provide, here are the list of keys that are valid. And if it doesn't find that, it fails entirely until you change it. That way, at least there's consistency across platforms. So you can either encapsulate the list of keys by some name and put it somewhere, or you can just provide a list of keys that are valid for a platform. And the idea would be that if you run that on Pack will only look at those keys and process those keys. It'll ignore all the others, and that way you get reproducibility between Pack, Kpack, Tecton, or whatever, until you find the minimal subset that's compatible with all the platforms that you're interested in.
So the like equivalent here would be like in the project descriptor parser functionality, we're adding the lifecycle that translates it into something else that, platforms could use that or provide that with a list of keys, or kind of use that to help validate Project TOML and reject in a very consistent way and fail to build in a very consistent way when certain parameters aren't there. And so we can kind of help platforms with that validation. And then on the Google App Engine side, if they're going to use the project descriptor parser, they're going to have to say, yes, they're going to have to explicitly say that they support all these fields and that ignore them in order to get their Google App Engine build to not fail. Otherwise, they're going to inherit failing when Project TOML is specified. And so maybe that addresses the App Engine thing.
So that's the allowed list of keys. The other thing I would like to see made consistent across platforms is overrides. So if there is such a prepare binary with a list of allowed keys, the platform should have a way of providing overrides from its own configuration down to that prepare phase. So let's say Pack currently allows for builder to be set as a flag in its CLI, and that overrides what's provided in the project descriptor. So whatever that prepare binary or whatever that is going to be should be able to accept these options from various platforms for the list of allowed keys and provide a consistent way to override those values from. So if there's a platform like Kpack, which defines its builder using like a YAML resource manifest, it should be able to pass that into the binary saying that this is the builder you're using, not this other one that you defined in Project TOML, and I'm overriding it because it was defined by the platform or overridden by the platform, or whatever you want to call it.
So I think that's at least akin to what I was aiming for with this, and sort of like another layer of like Pack TOML. And again, I'm like really open to changing the schema of what I'm calling Pack TOML here and how it works and everything. But that idea of sort of layering, and even down into, I think the further layer down that you were talking about, which is like the prepare phase or whatever. You're having a layer that is platform specific, having a layer that's generic, and then having the life cycle, which has a way of potentially accepting or rejecting things. So we could circle around that a bit, but I think I'm somewhat aligned with it.
The reason sorry. Go ahead.
No, I was gonna say I should give Javier a chance to talk about his proposal. We can keep going around on this.
Check, we're at half past if we want to move on to other topics.
One last thing I wanted to bring up though is I think it's important to focus on what are the problems we're actually trying to solve. And I know like we spent a lot of time honing the reverse domain name part of it, and what I'm not hearing from users is Project TOML is hard to use, the schema is weird. I don't even hear really anything about the name of the file. Like, yes, one of the problems we're trying to solve is that we want to advertise whether it's a build packs compatible project or that it works with Pack and that kind of thing. But what I'm hearing from users is like, I want more of this. I want new tables in the Project TOML. I want it to work across platforms. And so I think it's important to keep that in mind. Like, the problems we're trying to solve are not like, oh no, Project TOML isn't working. I think it is actually providing a lot of value to users. So there's no need to like burn it to the ground. Let's solve the problems that we're hearing about. So
I agree with the principle. I feel like users, because there's no descriptor file right now, introducing any kind of descriptor file is going to get a lot of positive feedback. A user that knows that the Project TOML exists already isn't going to give us feedback that they didn't recognize that it was a build pack app, or like the name is something that I think is you only get.
Yeah, I agree that's a problem.
Lack of
I agree
feedback.
that is one of the problems we're trying to solve. Yeah.
I wonder if you ask people directly, right? How do you feel about the reverse domain name notation and having everything nested under domain keys, right? I don't know what feedback we get, but I feel like it's at least unusual compared to what other things are doing.
That might have been a good question to ask when we worked on that RFC, though. I don't know. It's kind of weird to me that we spent like a month refining that, and now we're like, oh no, fuck it. Like, it's so weird to me. Like, what? Unless there's a good reason to. And I agree. It's good to get user feedback, but like, I don't think we have any either way. So why would we reassess our position on it?
For me, is a really specific reason, which is when Project TOML's goal was like, let's incubate a new general descriptor file, like way in TOML of describing applications that can work with a variety of tools. I think the reverse domain name notation, in that context, makes sense, right? Or like it's a way for any organization to encapsulate any configuration about a project, and domain namespaces are common, reverse domain namespaces are common, people understand that. But as soon as it becomes a specific build packs file, then anybody who looks at that isn't going to understand or have there's not going to be any reason why, we require all keys to be nested under the build packs domain inside of a build pack specific file, right? It's not that I think it was always weird. I think the decisions that were made in the past made sense in that context. It's just, if we're going to make it a build pack specific file, then I think it become pretty weird.
Is it weird if it's a build pack specific file or a pack specific file?
Either. I think it makes sense if it's a totally generic file, right, where it's non-specific to any tool, but not if it's a build pack specific or packs, or if it's specific to a particular tool.
Like I guess like the question for me is, how does it work if you want a build pack file that supports multiple platforms?
Yeah, I think it's like kind of. Sam described an approach there, right? Like, we encapsulate all the build pack specific stuff in the file. If there are things that are build pack specific, but some platforms support and some don't, then we have a way of those platforms validating whether or not those keys are accepted and failing to build. If you specify keys that aren't accepted, that can be built into the prepare phase. And then if they're really platform specific fields, like pack has a pack special do something, or kpack has a kpack special do something field, then we can introduce a platforms table that has truly platform specific configuration in it for fields that aren't specified by the project at all.
Just for brevity's sake, if you all don't mind, I could maybe take hopefully 2-3 minutes to go over my RFC. And I will put in the caveat that this just adds more ideas, but at the end of the day, I think what Sam proposed is something that I've now been leaning towards, and something that I'll probably at least try to work with him on putting together yet another RFC and see how that goes. But anyways, I'll go ahead and share this just to, again, kind of get a full picture here. So this is a build packs config, right? Personally, I don't care to bike shed over the name of the file itself. But at the end of the day, I would consider this an evolution of the learnings from the project descriptor as it currently stands. And the motivation for this is actually 3 things. For me personally, it's cross-platform support is the biggest pain point, the biggest challenge that I'm trying to solve here. Some of the other things incorporated in this RFC are moving, or kind of trying to address that obscure idea of the file name itself from Project TOML to something more specific. And then lastly, to your point, Stephen, the idea that if it's a build pack specific thing, you no longer need this sort of like nested, there's unnecessary nesting for the properties there. So basically what it is a build packs dot extension. I enjoy YAML more than I enjoy TOML. So that was kind of my little thing in there. It's like, it'd be cool if we could support both. And what I did is I threw a lot more configuration on here than what project descriptor currently has, to try to paint the picture of what PAC's options currently are, right? What a platform's options typically would be. And then keeping in mind that some platforms are not going to support this, we'll talk about later how we build that into what's called a converter, essentially. But basically, we have this TOML here. There's the YAML on this side for it. And let's see. So basically, it relies a lot on what Natalie's prior work on what was called a converter and this notion of an application API. So this project descriptor would be something that is part of this application API. And the reason why I did that is because right now it's an extension spec for defining the schema of the project descriptor, but there's nothing that says how this file should be used, right? And so the application API now starts defining how this file should be used. And the idea is that you have it in the source, the platform would essentially take that over to the converter, and the converter would yield back a platform.toml file. And that is a platform API specific file that now the platform itself understands. Some of the things that I wanted to incorporate into the converter were things about allowing the platforms to specify sort of like validation rules for being able to say that, hey, I don't support, the builder property, right? So if the builder property is provided, the converter itself could throw those sort of warnings and that sort of stuff be built into that piece there. That's pretty much the gist of it. And like I said, I think now we're talking about expanding the converter to be more of a preparer, and the preparer be a swappable component that different platforms could actually swap for their purposes, because platforms are having to prepare the environment already. So might as well kill two birds with one stone.
So I think the converter, like, I think we should separate that from the descriptor itself. Like, the converter could work, this could work exactly the same way for Project Toml as it is today. And in fact, that was like the genesis of the Google Summer of Code project, was a prepare phase that, turned Project Toml into like a platform Toml. So I don't think I don't think that is necessarily coupled to this proposal. But so aside from that, like, how does the schema of the file you're proposing solve cross-platform portability? That's not clear to me. Like, what inherent in the file solves that?
Nothing in the file structure solves it, right? This RFC is painting a new picture of something from what we all just discussed right now, right?
Okay, so burn it to the ground and then start over is what you're saying.
I call it an evolution.
That's what it feels like.
I call it an evolution, but yeah, if that's the way you want to take it.
I think we can, we can, if we want to be backwards compatible, we can still do what I proposed with Project Toml, just by introducing those new allowed, like an allow list of keys and overrides. But I think that also implies that we'll have to support it as part of our implementation, and that it will become a more concrete part of the platform API than what it is today. It's optional in the sense that you can block list all of those keys and you don't have to support it. But if you do support it, there is one way to do that. There's not 1,000 different implementations of parsing the project descriptor and then applying those changes.
I mean, Stephen alluded to this, right? What is our stance? And maybe this is kind of the root kind of challenge that we're trying to maybe avoid. But what is like the stance on project descriptor as it stands right now, the project Toml file, and whether or not that's going to be something that we're trying to incubate to be a generic file? Because if we answer that question, right, then that tells us where to go, or that could influence greatly where we want to go with it.
I just want to interject on timing. Do we want to just bankrupt the other topics and push them somewhere else, or do we actually want to move on? Not to cut off Javier's question, because I think it's an important one.
If nobody has a strong, stance on it at this point, maybe we could marinate on that question. But it does seem like that's a big sticking point.
Maybe we could pick this back up at office hours.
I won't be able to be there, but yeah, if there's anything, I could review the recording afterwards.
Sounds good. I definitely have some feedback on the structure you're proposing there, but we can take it async. Should we move on to the next item? So there was 182 that's still in the project descriptor stuff on project descriptor converter. Did we want to move this and the, sorry if someone said this already, did we want to move this and the, or to, do we want to take all the project descriptor stuff and talk about it later, or do we want to move on to the
Yeah, I
182?
think they were like one collection of just time wrap.
Yeah.
So let's move on to 186 then.
Yeah, I hope you don't mind if I talk about this one again. It's been a while, so I just want to reiterate some of the major points to get us on the same page, right? So the purpose of this RFC was to basically be an addendum to the previous accepted RFC about SBOM, right? The previous one introduced SBOMs provided by build packs, but for scanning tools downstream to consume it and get a full picture, a full SBOM of the application image, it's nice to have the base layer, run image, stack, whatever you want to call it. It's good to have a SBOM for that one as well. And they can merge it themselves or do whatever they want, but as long as it's present on the file system, right? So this RFC was just basically not really implying any implementation work from our side, just a format, right, for how this SBOM will be laid out on the file system and labeled as on the container image, just so that these downstream tools could pick it up, right? And the last time we talked about it, and forgive me if I'm butchering this up, right, but the last time we talked, I believe one of the sticking points was around basically the whole thing, right? The sticking point was that the RFC is fine for the world today, the build packs world today, but you imagine when the support Docker files RFC comes out that introduces this gem packages executable, which is supposed to be run after every extension, and presumably put an SBOM out after every extension. How do we exclude this gem packages and whatever dependencies it has from the final application image, right? There were some other points, but forgive me, Sam, I think that was the major sticking point. And if we can address that, maybe we can move to other ones.
Yeah, that was the main point. I did try to do a POC of what an in-image, base image SBOM generator would look like. Using the current tools that we have, it's not pretty. It's a lot easier to do this outside the image when you're scanning the whole image as opposed to a specific directory, because it's very easy to include dependencies from that SBOM scanner in your output SBOM. So it becomes really hard to do this inside the image you're scanning if you're scanning the whole image.
Why not just exclude the, or you mean while gem packages is running, gem packages is going to find its own things?
Yeah, I mean, gem packages we're assuming is this ideal Go standalone binary, right? That may not always be the case. If it has any dynamic dependencies in terms of libraries, any other dependencies it pulls in, then you've polluted your actual base image with a bunch of things it doesn't need, and scan that in the output SBOM.
Well, scanners generally support a -- exclude or whatever, and you can say if you have any dependencies, you have to put them in the directory next to the gem packages file. If you have dynamic libraries, set LD library path. You do that all over the place. Sorry.
Let's say you install Tone, for example, and you install that as like it's a Python application. It'll include a bunch of Python dependencies that it has. It's going to be really hard to find all the Python dependencies that were introduced because of like turn and exclude them. Like it's not just like shared libraries, like it's like Python packages and their metadata. It's not
Python path. It's Python underscore path. You could set, put it all in one directory, and then that layer doesn't make it in final image.
You can do it. I'm not saying you can't. It's really ugly. And I think it's a really bad user interface if you want to make this easy.
There are a lot of other options besides turn that are single binaries that are completely statically linked to do this though, right? Like for generating.
I just know one, which is Sift.
Sift and also the Cyclone DX tool is .NET.
The Cyclone DX tools are implemented in the language they scan. So the NPM one uses Node, the Python one uses pip, the Go one uses Go, so that's standalone. But all the others are implemented in the language they scan.
I guess the Cyclone DX CLI doesn't actually do scanning. That's right. Well, there's Sift. I mean, you can. I mean, is it really that hard to configure turn to? Actually, does turn support running in the context of a container at all already? So like, it's kind of a non-issue for turn, right? Because it can't generate.
I'm saying we are excluding a bunch of good tools that are meant to do exactly this, which is scan base images, because we have this restriction of running it inside the base image, which pollutes the environment anyway.
So that's not an issue with the run image SBOM RFC though, right? That's just an issue with the Docker file RFC. Like that's an issue with gen packages in general.
But I still haven't seen in that RFC how do you generate that file in the first place. I see that it's a path on the image. How do you generate it? Like, how do you generate it, attach it so that it's available?
Gen pack. The SBOM file.
One, yeah.
So
I asked for some details on like some tooling that the project provides that makes it easier. And that tooling should ideally carry over to whatever we support next. So this RFC we can approve and merge if we just provide some proposal for tooling that will allow us to generate those SBOM files in that manner, and then we can modify the support Docker files RFC to make sure that it can also do something similar.
Well, why does this RFC doesn't say you have to use gen packages or run anything inside of the container to generate it?
You need something to attach it in that way, right? Like it does introduce adding diff IDs to the output container image of that's not a normal, my qualm with that was that's not how we generate stack images today. And currently stack images can be easily generated using a single Docker file. So when we move to this, that won't be the case anymore. And that's a thing we introduced as a project. We should provide tooling to improve that experience.
Got it. So you're just suggesting in the RFC, we should say, as a project, we can provide a tool that lets you stamp, you give it an SBOM and it stamps it on the image and writes the, it's a diff ID, right, of the layer. Anthony, are you amenable to making that change?
Yes, of course. It's just the hard question wasn't really answered there, right? Like, is it assumed that it will be an externally running, what is it, bomb creation tool in that case?
To create the stack image, I think so. And then I think Sam's point is that gen packages, it's not that this introduces a problem with gen packages. It's that in general, gen packages has an inherent problem that's unrelated to attaching the thing, which is that it's going to pick up, the scanner may pick up its own dependencies. We have to figure out, are we comfortable just saying you got to use Sift until there are other tools, or do we need to say, do we need to come up with a different way of allowing for dynamic extensions to specify a updated SBOM, which I think is going to be really difficult if it's not running in the container, but we can figure it out in that
I
RFC.
think like the option that I was thinking about is that you can include whatever this binary is in your build image. And when you're creating run images during the extension process, they would have to be published to the registry or somewhere, right? I'm guessing registry or daemon.
Somewhere.
And then hopefully whatever this gen packages tool is can scan that image the way it typically does running on the builder or build image. So you give it the run image reference, and whatever that is, it scans it and outputs an SBOM somewhere. Then the lifecycle is responsible for attaching that later on in the same way.
It introduces a coupling between the build image and the run image.
Or I mean,
they might be different architectures.
Yeah,
even.
Somewhere in the builder, I'm guessing we have to put a lifecycle, like I'm guessing we have to put what canonic or lifecycle or whatever, some binary somewhere where it does not get wiped between builders changing. And
There was one suggestion I really liked. I don't know if it still applies, but make this a quote unquote utility build pack, this bomb generation tool, as you know, so it's not really provided by the stack author, but you know, that way it's always present and we control how it runs and what it does, right? Are we still seriously considering?
how would you create a build pack that follows the build pack API and is able to scan the whole image while like excluding build pack specific layers so that it doesn't intrude onto other build packs as bombs? And like the main issue I have with it is like, how do you like once you're inside the build pack, you don't know the layers directly. Those variables are stripped out, like the top level layers directly. I'm not talking about this one. I'm guessing you can make some assumptions about what those are and try to exclude them, but that's not part of the spec. The other option I was thinking about was, and I was actually hoping to write an RFC about it, which is what if Pack could do this on the fly? Like currently we need something to merge the SBOMs anyway, or like whether it can be a platform specific concern where if the platform is given an image and it's supposed to generate the output SBOM, it's not like we are going to use some special tool or we'll have more information as the image builder about the run image or the build image. So when we are scanning those images, the amount of information we have would be the same if we use some tool later on. So
and would that work in rebase too, right? Other platforms can rebase, not just Pack.
So I'm saying you move the concern of generating the run image SBOM to when you actually ask for the SBOM, not attached to the image. So when it's, let's say Pack has a Pack scan image or Pack something like that, which gets all these SBOMs and runs a tool like Gripe to actually scan for vulnerabilities. What it can do is it can fetch all the build pack SBOMs, push them through Gripe and get the reports, and then similarly take the run image reference that it has access to, run them through SIF and then through Gripe to get the final report. So the run image SBOM like is dynamic, but if something like Pack supports quickly generating an SBOM from the final application image, that also solves the whole thing. You just end up with a different solution.
I personally, I don't like that interface. You know, I'd like, you know, for these, you know, whatever persona this is, to not have to, you know, use Pack for this one use case, right? It'd be nice if it was just all bundled together. it doesn't have to be in the same image, right? I know we discussed it. It doesn't even have to be in the same application image. It's just somewhere, some container somewhere, right? That you know it's published and
Something
stamped and
back.
everything.
Right.
What?
What is the accuracy of those scanning tools and discrepancies between different scanning tools?
For scanning what?
The run image, the run base image.
I mean, you can pick any of them, but as soon as you get to the point where you're using a run image or a non-Bullpacks like interface to create the image, you don't have actual data anyway.
Right. So I guess my point is, I'm assuming it'll vary quite significantly between different
Yes.
inspection tools, right? And I guess that's where maybe a concern of mine lies, is that Pack might choose a tool that might not be the right tool for somebody else. And then I wonder if we're essentially either adding that, or whether we're adding value to begin with by doing that.
That was an example, but I don't see a good way of attaching the SBOM for the run image dynamically inside the build container.
Okay, well, that being said, you know, I am looking for next steps here. Can I get an agreement that if I update this RFC to have a, you know, pack attach method, right? I think that's you know, some way of Pack taking a pre-existing SBOM, we don't know how it came about, right? And attaching it to a run image and putting the diff ID on some label. We're also making sure that it's one existing layer. It has to be one existing layer specified. We can maybe move forward with this for right now, right?
Yeah.
All right. I'll make those changes, but you know, I know there were some follow-up conversations, and happy to have them.
Yeah, I still don't know how support Docker files will work, but for the state of the world as it is right now, that works. It's just that whether we as a project are ready to change this significantly when we get to support Docker files or not.
Thanks.
Yeah, I think we can. There's definitely stuff to figure out in the Docker file RFC for sure. I think we're at time, so we'll pick up the remaining items in office hours.